Good morning. Welcome to another programming day. All right. So before we will formally start our discussion, I would like to request all to fill up to sign in to our attendance form and at the same time rename your name, whatever name you have placed in our participants panel. So some of you use nicknames, so make it sure that you have typed your complete name. And then last, make it sure that your microphone is set to mute, not unless if you are requested to open or to talk. Let us start our discussion today with a prayer to be led by Annie. Amen. So today we will be discussing about for loops. And with that, we will be guided, or the main objective is to understand and predict the behavior of for loops, be able to write valid for loops, to describe and give an example of the initialization statement, condition, and update expression parts of for loops. And last is to know and understand the flowchart representation of for loops. So far, when we wanted to perform a task multiple times, we have written redundant code. So when there is a presence of redundant code, then we can use for loops as the expression or as the statement goes. In this example, we have print ln, 1, 2, 3, 4, 5 lines of print ln repeatedly expressed, wherein this line can be simplified using for loop, and these 5 lines can be expressed into 2 lines using the for loop command. And what is that? That is just the for int I equals 1 and I is lesser than or equal to 5, and then I plus plus. And release down that one statement system that out that print line. This command will give you 5 or similar output like this. So in this example, we release 5 lines of print ln. Okay. And the function is just to jump to the next line or create 5 lines, 5 blank lines, because we did not express anything inside of that open and close parentheses. So this is the output. But in our coding, we release 5 statement of system that out at print line. Wherein, if we're going to use no for loop, these 5 lines can be simplified into 2 lines, the for loop and then the code itself. So how did be? So this is now the code. All right. So this is the code. So we just simply express again this line and then the last line. And our goal is to create not 5 empty lines between that of the program, concepts of programming, and introduction to computing. So let us try. Okay, there is no difference in the output, but there is a big difference in the coding structure. Wherein the first one, we release 5 statements, but by when we use for loop, we just created now 2 statements. So that is a big, save or a way of saving resources of your computing experience. Okay, so what is then for loop? Yes, Jose. Okay, it's a block of Java code that execute a group of statements repeatedly until a given test fails. So the general syntax is the for keyword and then the open and close parentheses. You have initialization, test, update, and then statement. But how it works, how does it behave? So that explains now the semantics. So the semantics of the behavior of for loop is that it will perform first the initialization, which is once. It will read the initialization at once only, and then followed by the evaluation of the condition. If the condition is true, it will perform the statement or the body of the loop. And then after a statement is being performed, it will go now to the update part and go back again to the statement. To the condition. If the condition turns now to false, then that's the time the for loop body ends. So again, the behavior is initialization will be read once. It will evaluate the condition, perform the statement, update condition again. If it is false, then it will exit in the loop. Example. So we have an example of a loop and in an integer data type. So the simplest way to use a for loop is to loop over integers in given range. So for example, int I equals 1 and I is lesser than the value that you will set, and then the update part. So here we initialize the value of I to 1, and then our condition goes as is I lesser than or equal to 6. If this statement is true, it will perform system.out.print ln I plus squared is, and then it will perform the expression I times I, and then after that, it will update the value. So that's how it works. So for this one, the output is as simple as 1 squared is 1, which is it will compute the squared of the value of every value of your I. So our value of our I is from 1 to 6, and the incremental value is by 1 because of the operation that we use here, which is 1 I plus plus, or it will increment by 1. But if we will put here as I plus equals 2, then that means the interval is by 2. So if it is I plus equals 3, then it will be by 3 as well. So 3, 6. So that's how it depends on what value you have put in here. So let us try. So this is now the value. So as expected, so it will display the value of I and its square value. But the interval is 1. So that's why we have here 1, 2, 3, 4, 5, and 6. But if we will change that into 2, interval of 2, that can also be possible by doing such plus equals 2. And that will give us a 2 interval. So let us see. All right. So we have 1 plus 2 equals 3. And then plus 2 equals 5. So that's the interval and the square root of each value of the I. And then if it's 3, does it also possible? It's also possible. So 1 plus 3, that's 4. And the next value of our I is 4 plus 3, that's 7. And that makes now the value or the condition into false. So the update value here the condition here would depend on how you update the value of your I, which is also the variable of your condition. So that's how this code works. So the for loop flow diagram describes or gives us an explanation that first, it does the initialization of the expression once. So it only reads the initialization once. It tests the condition. So if the statement is true, it will perform the loop body, or it will execute the loop body and then update the expression. So before it will test again the condition. And if it is false, it will now terminate the loop. So that's how it works. Again, I will repeat. So the semantics of for loop in a flowchart diagram simply tells us that it will initialize the expression once. It will test the condition after the initialization. If it is true, if the condition is true, it will perform or execute the body and update the expression before it goes back again to the condition and evaluate it again. And if it is false, it will now terminate in the loop. So let us walk through to the example that we have tested a while ago. So but this time we will limit our value to 3. Okay, so how does it happen? How does the I transition? And why is it that the output goes in that way? So we will trace it one by one. So we have int I is equals to 1. So why is it that my I here is 1, Marcia? Good. That is because of the initialization here. So if I will put my I here into 0, then the value of I here is also 0. Next. The next step is to evaluate the condition. So what's the condition again, Annie? All right, so the condition is 1, which is the value of our I, is lesser than or equal to 3. Is it true or false? Neil? Yes, it's true. So it will execute now the body and update. So that means system.out.print line will be performed. 1 is the value of I plus the word squared is plus it will also execute the expression 1 times 1. And right after that, update. So 1 is the value of our I plus 1 that becomes our I into 2. Next, what's now the next or what's the value now of our I? John? 2. Okay, good. So is 2 lesser than or equal to 3? True or false, Annie? Yes. So execute the body and update again. So we'll perform system.out.println 2, that's the current value of our I, plus squared is, plus we will perform the expression 2 times 2, which is the value of our I. And then we will increment the value of our I by 1. So that means 2 plus 1, which will make our I into 3. So what's now the next value of our I? Nelson? Okay, so it's 3. Is 3 lesser than or equal to 3? John? True. So execute the body and update. So system.out.print calls on the value of I, which is 3, plus squared is plus 3 times 3. Okay, the expression, which is I times I, we just simply place the value 3, which is the value of our I. And then next to that is update the value of 3, which is 3 plus 1, as our update command says. It will increment by 1. So 3 plus 1, that makes our I into 4. What's the next value of our I? Leia. All right, so 4. Is 4 lesser than or equal to 3, Leia? No. So that means we'll exit in our loop. Okay, so that gives us a value of 1 squared is 1, 2 squared is 4, and 3 squared is 9. So here is another example. What if we are going to display only the squared values? In that case, the value of our I is from 1 and we increment it again by 1. So that means this value will give us what? Marie. Okay, good. How about Victor? Very good. So that means it will give us 1, 4, 9, 16, 25, and 36, which means a square of the value of our I. So we will try. Here, we are just going to get the square of the value of our I. So as you can see here, the value of our I is 1. So 1 times 1 as our expression goes. So that gives us 1. That gives us 1. The next value of our I is 2. So 2 times 2, that will give us 4. Next is 3. 3 times 3, that will give us 9. So then we will have 4. 4 times 4, that will give us 16. And then next is 5. 5 times 5 will give us 25, and so on. But what if we're just going to place here the value I? What will be the result? Marilyn? Josephine? All right, so it will just simply display the value of our I, which is from 1 to 6. So let us see. There you go. 1, 2, 3, 4, 5, and 6. What if our update here, I will change it into by 2. What will be the output? So that will be 2, 1 plus 2, that will be 3. Then 3 plus 2, that will be 5. So let us see. So we have 1, 2, 3. Why did I stop to 5, Annie? Yes, because 5 plus 2, that would be 7. And 7 is no longer lesser than or equal to 6. Let us have some simple exercise that will exercise the use of for loop. Now this time, create a for loop to produce the following output. So 10, it will produce 30, 20, 10, 0, negative 11, and then negative 20. Next is negative 7, 3, 1, 5, 9, and 13. At the same time, you're going to create another for loop that will display an exclamation point, apostrophe S, 200 lines, 200 per lines, 1 million per lines, and 5 per lines. Each of these number will be of one equivalent file name. Okay,